Hello math class, second hour, pre-calculus. Welcome to our presentation. I'm Ben Close.
I am Jamie Fabiano.
I'm Forrest Nelson.
And let's get to math. First things first, we're going to learn about the sine and cosine curves. Just a little basic stuff, otherwise you won't be able to understand it. Here's a sine curve. As you can tell, it starts at the origin of 0.
Alright, so now I'm going to teach you how to find the amplitude and transformation of a sine curve. Alright, so as you can see in the original sine graph, our amplitude is 1. So our sine goes up to 1 and down to -1. In our example problem here, our problem is 5 sine x. Now the 5 in front of the sine influences the amplitude. So when you come down and you draw it out, since the sine graph, it still does start at 0. But since the amplitude is 5, our sine graph is a little something like this. Our amplitude makes it go up to 5 instead of 1, causing the sine graph to be stretched out a little bit.
We will now be talking about the period of a sine curve. As you can see, an example, f of x equals sine 2x, and 2 is b, so we put 2 pi over b, which will be 2 pi over 2, which equals pi, so the period is pi.
Alright, here's the cosine curve. As you can tell, it starts at origin of 1. Very interesting, a little different from the sine curve because of the origins. Otherwise, it is the exact same.
So, where we have our asymptotes, those are located where the zeros on the sine graph are located. And for our wave, the locations of the origins are the zeros of the cosine graph. That's how we get our tangent graph. Our cosecant graph is the opposite of our sine graph. And as you can see, every time the sine graph goes up, that's where the cosecant graph begins. Each curve is at an amplitude of the sine one. And our asymptotes are at wherever the sine graph hits 0. So that's what our cosecant graph looks like. And there you have it.
Now we're going to talk about a secant wave. Secant is 1 over cosine, as we all know. So in order to help make the secant wave, we're going to show the cosine curve. The asymptotes are at the 0, and then you make a U shape at the peak of the cosine curve, as you can see there. Good? Good?
All good.
All good. Everyone sees it? Good.
There she is.
Cotangent is basically the same thing as tangent, but it flips and it moves over pi, 1 pi.
Hello, I'm back. I'm here to talk about describing the translations of waves. Alright, now we're going to talk about describing the translation. Alright, as you can see, the amplitude would stay with A. The period would be 2 pi over B, and the phase shift would be of C, and the vertical shift would be of D. That may sound confusing now, but here's an example. Describe the translation of 5 cosine 5x minus 4 plus 6. Amplitude of 5, easy. Period of 2 pi over 5, see that? Simple. Phase shift to the right 4/5. You take this, solve for 0, and then it would be to the right because it's a positive. Then a vertical shift up of 6, once again, because it is positive. Great job. Alright, now we're going to talk about solving for x between 0 and 2 pi. The first problem, sine of x equals 1/2. As we all know from Mrs. Wallace teaching us very well, sine of x equals 1/2 equals 30 degrees. And as we use our all students take calculus, we learn that sine is positive, so the 30 degree is positive in the first quadrant and the second quadrant. So it would be 30 degrees and 150 degrees And also, since we all memorized our unit circle very well, we know that it's pi over 6 and 5 pi over 6. Okay, now on to our second problem. Cosine of x equals square root of 3 over 2. And as we all know, it equals 60 degrees. And also, all students take calculus. It is positive in the first and fourth quadrant. From the unit circle, we learned that it is pi over 3 and 5 pi over 3 in the fourth quadrant. Alright guys, hope you guys had a really fun time watching this video. Hope you learned a lot. It's been really fun. Forrest, you got anything? No.
Thank you guys for watching. I hope you learned a lot.
We sure did.
We really
I learned
did.
a lot.
You know, this is a really fun experience for us. Catch you later.
Hey, what's up?
Hey, what's up? Keep going. It's just gonna keep going. I'm ordering.
Alright. Okay, I'll just start from now. Put the hand right here. Hey guys.
So here's our tangent graph. Here's a little visual of it. As you can see, in the tangent graph. I'm going to teach you a little bit about the tangent graph. Alright. Here's our tangent graph. What this graph does is...
Wait, someone help me.
No!
Someone help me.
Come on. Alright. I'm going to teach you a little bit about the cosecant graph.
Is this necessary, Nick?
No, don't do that. Please don't have that. Alright.
So what's your guys' opinion on the sine cosine waves? I think they're pretty nice.
Oh, hey guys.
Good to see you there.
Well, now we're talking. No, you are
Let's keep
talking.
recording. Let's keep recording.
Alright, I'm gonna start talking. Watch out.
Okay.
Okay.
What did you say?
I didn't say hello.
We're gonna talk about sine
Hello.
curve.
I won't
Say
laugh.
like we as a class.
I'll look at the floor.
Yeah, I'll look at the floor.
Get ready, I'm gonna talk
Get
about
ready, guys.
Guys, get
Time for
ready.
the sine curve.
Learn y'all.
I wanna learn.
So as you can see in the original sine graph, our amplitude is just, it's not there, so the wave just goes to 1 and -1.
Amplitude's
The amplitude's 1. The amplitude's not there. That means it's a straight line.
I was about to say non-existent. We Are you recording now?
Mm-hmm.
Get that out.
I haven't had water in 12 days.
Here it was.
Oh, that was your phone.
Jesus Christ. I took all my ones. My 4 of them.
Alright.